Good morning, grade sixes. Welcome to our digital lockdown school. Thank you for the morning wishes. I am feeling very well today and I am really happy to be back. So, welcome. We do have a few questions about the online schooling. Now, what you can do is if you don't want to, if you're not sure about whether you're schooling on YouTube or whether you're schooling on online, I know there might be a bit of confusion about that, but if you go to the African Teen Geeks website, you'll see that we have lessons on all the subjects, okay? And we're always going to be showing them via YouTube. So don't let that confuse you just because we're watching it via YouTube. That's the platform we're using, okay? Because I know there were a few questions about that. So if you want to know more about learning online, more about finding the homework and that, just email this, go to this website, okay? And you will find most of the answers to your questions there. All right, because I don't always know exactly what you're looking for certain things. Okay. So what we're going to do today is we're going to continue from our lesson yesterday. Fire is, as someone says, ma'am, fire is not a liquid, gas, or solid. It's a plasma. Now, if you're going to go to your advanced science when you're doing mixtures, then yes, that is going to be the final result for that. It is. However, it has to have one of the, or more than one of those states of matter. Okay. So today we're going to continue with our lesson. I am briefly going to go over what we discussed yesterday, just for those of you that aren't aware. And also at the end of this lesson, I hope it's on this slide for you that I have a nice, very interesting facts. And actually, Michael, what you brought up about the plasma and different things like that, the mixtures and that, I actually did add a link of where you can go on National Geographic and actually look at that. There's a whole little thing about that. And about the Newtonian and different, like if you're really into science, really into it, you can go there and you can have a look. So just watch out for that when we get there. All right. Now, we know, we've learned the basics that there are 3 types of matter, okay? And now we have to think about, can we recognize, like a lot of you guys ask me, ma'am, is this a solid, is this a liquid, is this a gas? So now we're going to do the basics of observation skills to try and figure out if we can recognize in normal everyday materials which is which. Okay, sometimes you have to use your imagination a bit. All right, we're going to look at a few of them and see if we can categorize them correctly. Okay, welcome everybody who's just arrived. If you weren't here yesterday, we do have our videos and PPTs online, our PowerPoints and worksheets on our website. I did show at the beginning of the slide and I will also show at the end. All right, and at least you can go, you know where to go to have a look. Okay, I don't want you to miss out on anything. So yeah, we have, good morning. Yeah, we have our table, okay? Now, this is just a basic one. I think you'll all be able to do it. We are going to say which material is kept in each of these containers. So inside each of these containers, what material is in there? So what is it? And then in the second column, you say what type of matter it is. All right. So if you look at the first one, we have balloons. The second one, we have a kettle. Third one, we have an ice tray. Then we have a jar with a closed lid. Then we have milk in a glass. Then we have oil in a bottle. Okay. So for the first one, what do we find in a balloon? Oh, I got some answers already. You guys are on the ball. Well done. Okay, that's looking good to me. Very good. Nice and easy one, eh? Okay, good. All right. Now, I actually did bring the answers onto the page today. Hopefully, they show themselves. So let's have a look if it's going to work. Working. Okay. So I put helium. And the reason why I put helium, yes, you can put air in a balloon. In the majority of cases, when we get our balloons blown up, especially if there's a lot of them, helium is just better. And helium is a lot better than air because helium actually floats better and it doesn't deflate as quickly. The balloons don't deflate as quickly as with air. And also, they do kind of fly very high. So helium has just a bit more buoyancy than air does. And you're absolutely right. Helium is definitely a gas. Good job, guys. Well done. Pat, pat. Now, for our next one, we have, yes, it makes your voice funny, although I don't really need helium to make my voice funny. It goes naturally squeaky sometimes. But yes, if you block your nose and you talk, then that's very close to what you'll sound when you use helium. It does affect your voice. And you can have a lot of fun with it. Now, there is, well done, for those who answered the second one, we normally put water in a kettle. Okay, we don't normally put anything else in a kettle. All right. And you're absolutely 100% correct. It is a liquid. Now, for the third one, I see we're already on that one. Good, well done. You've got an ice tray. So what is inside the ice tray? Very good. There's ice. And ice is considered a solid. Okay, so once it's in that form, it's a solid. All right. Then we have a jar, a sealed jar. What is in that jar? Very good, Sigle. Can you actually see anything in the jar? If you can't see anything in the jar, then we would normally say, yes, Shakira, that's right. We would normally say that it is air. Here we go, well done. It is air, and air is a gas. See how easy this gets once you do it regularly. So you guys are very, very good. You're doing well. Okay, so then we have milk. And what is milk? There we go. Well done. Oh, you guys are far more awake than me this morning. Well done. Excellent. So then we have a liquid. Very good. Last but not least, yes, we have oil. And oil is a, no, it's not alcohol. But that made me smile. Okay, so we have oil, and oil is a liquid. Yes. Well, it's okay, Bontle. It made me smile. You're all right. Don't worry. Okay, so you see how easy it is when we're simplifying. We haven't got to mixtures. We haven't got to solubles and insolubles yet. We are basically just talking about basics at the moment, just reviewing them. Okay, so let's review this one. Okay, we have a little table. This I did on for homework, which is why I'm also reviewing it. Some of you may not have done it. Some of you may have done it. You're more than welcome to send your homework to me. Okay, so yeah, we have pictures of particles. We have to identify whether they're solid, liquid, gas, and maybe give an example. Now, my example may not be the same as your example, but that's okay. As long as it fits in the category. So everybody's jumped on the first one. Well done. Very, very good. So you have, by looking at the articles, you have gas. And an example of gas, we can see here, we have air, we have oxygen, which is air, we have helium. So I just put air. Okay, but if you think of a different gas, that's also good. And then in the next one, what do we have there? Those particles are close together and they're very, very tightly packed together. There's no space or vacuum between them. There we go. Well done. It is a solid. That's right. Now, can you give me an example of a solid? I saw earlier someone put their ice. Any others? Michael, you are just going too far ahead. But I can, you know what I like is it really interests you. And that I think is really, really good, because when we go further along, you will actually discover that a lot of your questions will be answered. So we have rock, we have bones, we have table, bones. Oh my, yeah, oh, I remember our first lesson. Remember the bones? Okay, so I just put ice there. All right, so we have our ice, and then we have our, I went a bit too fast there. Can you give me an example of a liquid? Now, do you see how the liquid is kind of like close together, but is still vacuum between it? Yes, milk is a very good example, and blood and water. Well, juice, yes, juice is also a very good example. So there we go. Well done, guys. Soup, yes, especially on a winter's day. Soup is very good. Cool drink, well done. Cool drink would also fall under there. Okay, so these were actually the 3 questions that we started our lesson in the beginning of the week with. So we were talking about the 3 states of matter and how they are different from one another. So you don't need to write this down. You already have this information down. We're just revising it. So the particles in a solid are closely packed and have fixed positions. Particles in a liquid are closely packed, but they can move around each other. And the particles in gases have large empty spaces between them, which we call vacuum. This, I don't know if you want to take down, because some of these notes you may have, you may not have. You can do a screenshot, whichever floats your boat. Okay, so we have solid. The properties of solid is that they can stay in one place and be held. Okay. And then we have solids can keep their shape. They do not flow like liquid. And solids always take up the same amount of space. They don't spread out like gases. So we have to be able to compare them. Solids can be cut or shaped. And even though it can be poured like sugar, salt, and flour, they are still solid. Because if you go a little bit closer with your fancy scientific microscope, you would see. Now, each particle of salt, for example, keeps the same shape and volume. That's why it's solid. You have your liquids. Properties of liquids include that it can flow or be poured easily and not easy to hold. Okay, so you can't really like hold like water in your hand unless you have it in a container or in a glass. Okay. So I'm going to let you write it down. Don't worry, Kiara. I'm just going to read through it in the meantime. Don't be sorry. You can take notes, definitely. Now, liquids change their shape depending on the container. So if you pour liquid from a cup into a bowl, it's going to take the shape of the bowl. If you pour it from the bowl into a jug, it's going to take the shape of the jug. If you pour it from a jug into an ice tray, it's going to take the shape of the ice tray. So it does change the shape depending on the container. Now, even when liquids change their shape, they still take up the same amount of space. All right, the volume stays the same. Okay. Don't worry, I'm staying on this page so you can jot this down. All right, it's not a problem at all. So gases. So Michael, you're asking, I must actually take note of your questions as we go so that we can actually address it. So you're asking if we can change air into a solid or a liquid. So after the lesson today, I want to actually, Michael, do you have my email address? Have you taken it down? Because if you have my email, all these questions you can send to me, and then it's so much easier, and I can at least in the next lesson just answer it in more detail. Okay, so my email is on the slide, so I'll show it to you just now. Because you have really good questions, Michael. I like your questions. Ma'am, are marshmallows a solid? Well, are the particles in a marshmallow close together? Is there any spaces between them? Porridge is a mixture, which we are going to get to. Okay, so porridge is a mixture of your solids and your liquids. Do you send me your homework? Okay, then I have to look. I didn't see anything come up. I'll have to look again. All right, I honestly didn't. I checked my emails this morning. I haven't seen anything. I'm going to make a note of that. I'm going to have a look. Okay, so I'm just jotting this down while you're jotting that down. So let me see. Homework. All right. Okay. Thank you. Okay. So after the lesson, I will go and I will look at it. So some of you are asking for my email address. So what I'm actually going to do, let's see. I'm going to show you at the end of the lesson. Just can you hold on till the end, if you don't mind? I do have it there. Right, gases, the properties of gases are often invisible. I think you guys are honestly ready to go into mixtures now because that's where all these questions are leading. So we are going to go to that soon, really soon, because I think you're ready. Now, gases do not have a fixed shape. They spread out and they change their shape and volume to fill up whatever container they are in. And gases can be squashed. But like liquid, you can't really hold it in your hand unless it's in a container. All right. So we are coming to a point where we are going to discuss how to change, how to mix solids, liquids, and gases, how to separate them as well. We are going to do that. So I just want to make sure you have this down. Is everybody finished with this page, this slide? Okay. Kiara, where are you at the moment? Are you on? I know you've got such a nice class here. They don't mind waiting for you to jot it down. Okay, so Kiara's still doing liquids. So I want to actually see one of these questions. Liquids change to solids through freezing. Exactly. We are going to get onto the different forms as well of freezing and dissolving as well. And also the wetlands one, there was that question about yesterday, I think it was, that you asked about the wetlands or discussed the wasteland. So I have actually for next week, we are hoping to start on that as well. I do need to go through the processes with you first. Okay, it's very important. So like we all learn at different places. So Shakira, you have suggested that solids change into liquids through melting. That is correct. So you have melting, you have dissolving, You also have, which one did you mention earlier now? Where did I see that? Freezing. There we go. Okay, so paint is a liquid, but if you paint on a solid, will it still be considered as a solid? That's interesting. Don't think if it's a liquid unless it mixes with the solid of a building. Paint doesn't really mix with the solid of the building. It just dries on it. For example, if you mess water on the road or oil on a piece of clothing, it's still oil. It doesn't change into a different form. It's still a liquid. If water's on a road and there's a puddle, even though it's on the road, yes, it evaporates, but it's still, eventually, it's still a liquid. So that is actually a good question to investigate further. I like that question. So I'm going to actually jot that one down. That's a good question. So right, so is paint considered a liquid if you paint on a solid? Nice questions you have there. I love the way your brain's going. Very, very good. Okie dokie. So are we ready to go to the next slide? Okay. Okay. So I am going to go to the next slide. I hope that's okay, Kiara. Okay, so there we go. Now, this is one of the links that I did include in one of our slides, which we did not get to, for you to look at and study. But I have put the link on at the end of this slide as well. So you can go and you can actually watch it. Look carefully at this picture. Okay, what is happening? This is what you guys are getting to when you're asking me all these questions. All right. So yeah, we are. We have our gas, we have our liquid, and we have our solid. All right. Now, you asked how can they change from one to the other. Look at the direction of the arrows. Let's see what we can do. If you have a gas, it can become a liquid. How can it become a liquid? Through condensation. Now, I'm just going to, okay, there you go, Mushava. I'm going to jot that down quickly. How far are you? You guys can get these notes and the PPT on our website, okay? They are available there. And they will be recorded, the lesson as well. Okay. All right. Is this the page you wanted to go to? Okay. Right. So whatever particles skip matter? You mean not going through? What do you mean by that, Eddie? So you actually meaning when particles don't collide. Okay, so like a solid goes to gas. It has to kind of change before it can go into a gas. All right. Look at this image. You can even draw this image. Gas cannot go straight to a solid without going through the process of condensation. So it needs to go through a process of condensation to a liquid and then freeze to become a solid. Think of the weather. How does the weather work? So when gas changes to a liquid, it goes through the process called condensation. Okay. And when a liquid changes into a solid, it's called solidification. Okay. So they say that what we need to know right now is we just need to know this process. Okay, let's get to know the names first. All right. So we have gas that goes through condensation to become a liquid. Now we will go through each one once we know the process. Okay, first get this process down. So then you have your liquid. In order for a liquid to become a solid, it needs to be frozen. In order for a solid to become a liquid, it needs to melt. In order for a liquid to become a gas, it needs to evaporate. And that's exactly right. Water can be all states of matter in its different forms. You're absolutely right. So have you ever seen condensation on a window? So when your gas, your air outside, gets really cold, it causes condensation outside of your window. However, I don't know if you've noticed when you've been near a window or in an airplane and you breathe air and you breathe it onto the window, you're looking out a window and you breathe it on, you notice the air changes into these tiny, minute little droplets. That is called condensation. Okay, and that condensation joins together as a liquid. So that is how you can easily test the theory of air becoming liquid. Okay, so just any glass, even a mirror in your bathroom or a mirror in your room, just breathe on it, and then you'll see the condensation on the mirror, and then it becomes a liquid, especially if you wipe it together. All right. Now, in order for that liquid to become solid, it needs to be frozen. And yes, our best example is water, because we can even do that ourselves. We can take a glass of water, we can pour it into an ice tray of water into the freezer, it gets frozen, and then it becomes a solid. We see that out in nature as well. For example, snow, icicles, frost. It takes freezing cold to turn that water or that liquid into a solid. All right. So you can go the one way with it. You can go from gas to liquid to solid. You can go from liquid to solid. But you can also go the other way. You can go from solid to liquid, melting things. Obviously, they have to be at different degrees of temperature. So the one process involves making something very cold, and the other process involves something making very hot. For example, when it rains, as I said before, you imagine a puddle, a pavement, okay? So you've got this puddle on the pavement, and eventually, when it gets warm, the puddle disappears because it evaporates. And then you can't see it anymore because it becomes a gas. Well, in paper, when you put paper in water, what happens? It gets soft, okay? And it does disintegrate. Well, atoms are what you call particles. Particles are made up of atoms and molecules. So to actually specify what actually happens to the actual atoms in paper would require a lot more technical and scientific going into, which I don't think we have time for today. But remember, a particle is made up of atoms and molecules. So whatever is happening to the particle is happening to the atoms and molecules as well. All right, we just put it into one word, so it's just a lot easier to work with. Okay. All right. Now, what I need you to do is before I can ask the next questions, I need you to actually draw this drawing down. Take it down, draw it, sketch it, and then we can go into the questions because you need to have a look at this picture. You need to have it in front of you to be able to ask the questions, answer the questions. Okay. So I'm actually going to stop talking for a minute or two. I'm going to let you write this down. So please don't go anywhere. I haven't gone anywhere. Just really need you to write this down and draw this picture down. Can you do that for me? Yeah? Okay, so guys, draw this drawing down. Make it very simple. It doesn't have to be very fancy. Just be sure that your particles are correctly placed when you draw the little particles. Now, we will ask the question about the paper. Okay. Now, paper, molecules inside a paper are bound very close together. All right. And yes, I am okay. I'm just waiting for you guys to draw the picture. Okay, and I'm just answering Michael's questions about paper turning into liquid. So when paper turns into liquid, yes, it can be can go very soft. It won't turn into liquid unless it's heated up. So when you, for example, you know, when they recycle paper, they have to actually boil it. You actually have to put it in heat it up and warm it up so it can break down. Okay, when you break it down by boiling it and heating it up, then it can go into liquid state. All right, so the temperature must be below boiling point and above melting point, if that makes any sense, Michael. So obviously we'll go into that now, but it must at a certain temperature to change into that liquid state. And when it changes into that liquid state, then you can literally pour it into a mold or pour it into a different way so that you can actually make new paper from it. You with me? I can definitely find a better way to explain it to you if you want. Is there anybody else that can't hear me? Because someone can't hear me. I don't think it's from our side. I think it's their side. Be their audio. Right. So Michael, you with me there? Okay, awesome. All right. Okay, good. Now, does anybody still need to draw this down or need to take it down or something? Or can we go to the questions? Okay. All right. So we go do the questions. Okay. Right. So yeah, I've actually put the picture here. It's just not as big. Okay. Just a little bit smaller. I've separated the questions so that you can at least see them a bit nicer. Here we go. What do we call these? Are easy. Remember I said I was going to do Kahoot. Some of these questions might be in there. Okay. They'll be really, really nice and easy. What do we call a solid state of water? What do we call a solid state of water? Anybody know that? Oh, shame. Thank you very much. So what do we call a solid state? Yes, we call a solid state of water. So if water turns into a solid, it's going to be ice. Ice. There we go. Okay, so what do you call a liquid state of water? Okay, so yes, it does sound weird because you're saying the word liquid and water and you're like, what do you mean? It already says water. Okay. Let's see the next one. What do we call a gas state of water? Okay, I'm sorry if my voice, I don't know why it's going. Very good. No, that is actually very, very good. Water is one of the best examples to use because water is a liquid. Water can become a solid by ice, and it can become a gas by steam. Okay, and even condensation. So let's see. What do we call, now this is the process I was telling you to look at. We have different names for the different processes. So if you look at the image, what do you call the process of ice changing to liquid water? So yeah, is your solid, your ice, and it's got to change to liquid. So what is that process called? Well done. There we go. There we go. Excellent. It's melting. Well done. It's melting. Okay. Then what we're going to do next is we're going to look at what do you call the process of liquid water changing to ice. So now if I have to change the water now to ice, so we're doing it the opposite now. We're going the opposite way. Yes, exactly. Well done, guys. It is freezing. It is freezing. I think I'm going to turn into a solid soon. It is freezing. What do we call the process of liquid water changing to water vapor? So now the water is going to change to water vapor, like steam. Yes, well done. Excellent. Very good. So if you change from a liquid to a gas, it is evaporation. Well done. If you go from, let's have a look at your next question. What do we call the process of steam? Now we're going the other way. We're going from steam to water, liquid. Yes, you're on the ball, guys. Well done. Awesome job. Well done. Do the particles in ice change when the ice melts? So if I have an ice block and it's melting, look at the particles in the ice block. It's a solid. Now melt the particles. Do they change? Yes, they do. What do you notice in the change? Shape, yes. Very good. It doesn't have a fixed shape. It can take the shape of its container. Absolutely. Can you see they are close together, but they slightly separated. Well done. Excellent job. Now, let's have a look at ice and liquid have the same particles. Why do ice and liquid water have different properties? So if they have the same particles, okay, ice is solid and water is liquid, why would they have different properties? Because look, they have the same amount of particles. Okay, so they either become close or far apart. So that is the property. The property of it is very good. The amount of space between them, and and you stretched the lesson lots, Michael. Trust me, your questions have been absolutely awesome. I hope you do email them to me. So ice is a solid, very good, with a fixed shape. Water is a liquid, particles are further apart. That is a very, very good explanation, Shakira. Thank you so much, because now I can see your understanding, which is good. So how can the water particles in ice, okay, let's just finish these questions, okay? How can the water particles in ice be made to move freely? Think of the solid. How can we get the solid to move freely? What process do we have to do? There we go. I think this is actually the last question today. Here we go. We go through the process of melting. Process of melting. Now, well done. You did very well. Now we can actually move on to where we're going to start mixing our solid liquids and gases and start that process. Okay. This is for your information, because Michael asked quite a few interesting questions yesterday as well. And I think not only Michael, I think there were a few others. Okay, so you can go to this website, this link, all right? And this is the latest scientific information about particles. Remember when you asked if a phase of matter can be solid and liquid at the same time? Okay, well, this is what you were talking about. So you can go to this site, you can read up about this, and you can have a look at that. It's very, very interesting. All right. And this is what the homework sheet looks like today. So if you go on to our website and that, this is what your question will look like. This is what your worksheet will look like. Okay. This is some very good sites. I know that some of you, was it JD or was it Michael or somebody earlier on shared some very nice links as well that you could go and watch. This is what I want to show you. If you want to ask any questions, there's my email address. Send homework to me. There's my email address. This is the website African Teen Geek for any other subjects, any worksheets, any recordings, any videos that you might have missed, any PowerPoints you want to have a look at related to any subject in your grade. And please be more than welcome. Send me questions. I can actually look at them in my own time and be able to address them in the next lesson. Because your questions, I must say, guys, awesome. You worked very, very well today. And tomorrow we're going to start working on learning about our mixtures and reviewing our mixtures. Okay. Thanks so much for being here today. Thanks for your patience. I look forward to